Okay, let's take a closer look at the main screen of Nova DSO Tracker. When you open the software in the browser the first time, the default view will be a list of deep space objects sorted by their current altitude at a certain location. I will show you how to configure the software in another episode. Let for now focus on the functionality of the main tracking screen. On top of the screen, you can find the version number you are using. If you are using a different version, the functionality might be slightly different. Underneath you can find some important information that puts the data on the page in context. First, you find the mode Nova DSO Tracker is running in its either single or multi-user mode. Single user is the default setting, and I will focus on it for the time being. Underneath you find a button named Configuration. This opens the configuration screen, where you can customize the software. I will explain it in another episode. Right to the configuration button you can find the location selector. You can configure and select multiple imaging locations. Important to note is that all information you can see on the screen is linked to the location. That includes the next fields, date, and time. Moon illumination provides you with the percentage of illumination at midnight. Astronomical dusk and dawn indicate the time when it's dark enough to image. In the next row, you can see tabs that will show additional information about the deep space objects in the list. In this episode, I will focus on position and properties. Now we come to an important feature of the software. These two lines help you to define exactly the objects you want to track. The first line allows you to sort the content, the second to set filters. In the default setting, the list is sorted by the current altitude of the objects in falling order, and no filters are set. Let's take a closer look why the combination of these filters and the possibility to sort makes the software so powerful. Let me first explain all the fields available. I guess object and common name are quite self-explanatory. Object is the ID of the DSO, represented by its catalog number, so for instance M64 for Messier 64. And under common name you will find Black Eye Galaxy. Which catalog numbers and names we use is something you will understand better once we go through the configuration of the software. In both fields you can search for individual objects, or you can filter them by excluding or including certain terms. I will show you later in the demo how to do that. You can sort these columns, as all the others, by clicking on the title. Clicking multiple times will toggle between ascending or descending. Current altitude and azimuth show the current position of the objects at the selected location at the current time. All relevant data on this page will be automatically updated every minute. The default sorting of the table is altitude descending. That means the object from the list currently the highest in the sky will be on the top of the list. The green color of the field indicates an altitude above a certain degree. The default setting is 20 degrees. So if an object is 20 degrees above the horizon, the field turns green. The idea is to quickly indicate objects that could be observed or imaged. In both fields you can set filters smaller or larger a certain value, and also a range. This can come especially handy if you do not have a 360-degree view to the night sky at your location, and you only want to see objects in the list that are in an unobstructed part of the sky. I will show you how to do that in the demo. Trend shows if an object is ascending or descending in the night sky. The next two columns show an object's position at 11 p.m. It provides you a rough impression of which objects will be visible for the upcoming night if you are planning a session during daytime. Transit provides you with the information at what time an object will reach its maximum altitude. This can come handy if you want to image earlier or later in the night, for instance caused by a weather forecast, or if you want to find the best order to image multiple targets at the same night. Now we come to one of my favorite fields, the observable time in minutes. This field shows you the maximum time an object can be imaged at that night. The minutes shown is the time an object is above a minimum altitude between the time of astronomical dusk and dawn. So if you just sort the list by this field, you will instantly see the objects that are accessible the most. You can also set a minimum value so that objects that do not meet that criteria are filtered out. The next field indicates the maximum altitude an object will reach during the observable time. I guess you already can see why this screen is so powerful. The combination of these parameters really lets you zoom in to the best imaging opportunities at a given time and location. Let's say under observable you set a certain minimum time, an object should be visible. Now you add this field and select a certain altitude, or you sort it by altitude. This would narrow down your selection even further. Last but for sure not least is the angular separation field. It provides you with the degree of separation between the deep space object and the moon. Depending on the level of moon illumination, which you can see on the top of the screen, you can select a minimum distance as an additional criteria. Even if you decide to image in narrow band because of the moon's illumination level, you may still consider objects that are at the opposite side of the moon in the night sky. I'm aware that was a lot to take in, but we are not completely done yet. What I have shown you so far will allow you to select the objects by criteria like their position in the night sky, but what about being more specific, to match object better to your imaging rig or your personal preference? This is what we will look at now in the Properties tab. After switching, you will still see the objects in the same order as before, but there are now 4 very different fields. They have nothing to do with the position of the objects, but with their properties. This will enable you to be more selective in your choice of images you want to focus on. Let me briefly go through those fields with you. The first one is Type. Here you have the opportunity to filter for specifics like planetary nebulae, reflection nebulae, star clusters, etc. You can select one or multiple types in the field. Magnitude and surface brightness provide you information about how bright or dim an object is. Depending on your rig, you may want to set a minimum brightness of objects. Keep in mind that higher magnitudes or surface brightness means dimmer objects. And of course, size. Depending on the field of view of your imaging rig, you may want to select a range or a minimum size for the objects shown. Okay, after all the theory, let's get to the demo now. As mentioned earlier, you can sort any field by clicking on its title, and you can search for specific objects. Let's look for M42, the Orion Nebula. Here it is, but as you can see under Observable, it says 0. So it will not be visible tonight at the set location. You may also have noticed an additional button popping up. Generally, your filter settings will be stored, so you do not have to edit them every time again. That comes with a downside. Sometimes you may not see a certain object based on the filter setting. The appearance of the Reset Filter button is on the one-hand side a visual clue that one or multiple filters are set, and on the other hand side you can reset all filters with one click on that button, instead of deleting them one by one. Also important to note, this function goes across the tabs. So if you have a filter set in Properties, the button will also show in the Position tab, and clicking it will reset all L filters. Let's continue playing around with the filters. In case of an obstructed view of the night sky, we can set the 11 p.m. azimuth to a range from 100 to 300 degrees. Sorting the objects by the observable field shows that we would still have many objects as potential imaging candidates. So let's go ahead and set the max altitude to a minimum of 40 degrees above horizon and the angular separation to the moon at a minimum of 70 degrees. Let's get more specific now and switch to the properties. Here we select different types of interest, as well as a minimum size. Here you have it, a very condensed down list of objects that fulfill all our criterias for tonight's session. We can also see that NGC 6334, the Cat Paw Nebula, would allow for 650 minutes of imaging. We can click on it and we'll get to a much more detailed view. But that is for another episode. Here you have it, your first steps with Nova DSO Tracker. How you will use this powerful tool is entirely up to you, but I hope this introduction provides you with enough ideas for your own journey. Stay tuned to not miss out the next episodes, where you will learn how you get more information for a better planning, as well as how to configure the software to your needs. Until then, clear skies.